Welcome back to the channel for practice problems for actuarial exams. This is a practice problem for exam FM on financial mathematics. If you would like to get information about me, go to smarturl.it/Jedi. If you would like to see my advice on how to pass actuarial exams, go to smarturl.it/pass. I run online seminars for actuarial exams that you can find information about at this website, smarturl.it/btdt-online. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. The program is a Center of Actuarial Excellence and also a winner of the Casualty Actuarial Society University Award. And if you'd like to make a tax-deductible donation to our program, go to smarturl.it/help-ISU-actuary, and we'll use the money for scholarships for our actuarial students. Here's the problem. It's a problem in financial mathematics. Exam FM. A company is introducing a new product that they think will have a 10-year cycle, with sales increasing steadily for 5 years, after which sales will decline steadily. The company feels that the product will be so successful that they will make sales every day of the year. As a result, they model future sales by assuming net cash flows are received continuously over the 10-year horizon at the following rates: 100t for t between 0 and 5, and 100 times 10 minus t for t between 5 and 10. The company requires an effective annual rate of return on any investment of 12.75%. What is the maximum amount of money the company should spend today to invest in this new product? Well, the maximum amount is what they will receive if we discount the payments made to them at their required rate of return. If they pay any less, they will get a higher rate of return, so that's perfectly okay too. But the maximum acceptable is the present value of all the payments from the product at their required rate of return, which is 12.75% effective annual. But everything is done continuously in the problem, so we should do calculations using the force of interest. What is the force of interest when the annual effective rate is 12.75%? Well, 1 plus I is equal to e to the delta, not minus, e to the delta. So delta is the natural logarithm of 1 plus I, or natural logarithm of 1.1275. And using that, we can calculate the present value of the net cash flows as, well, they have an increasing annuity of 100 paid continuously, increasing continuously over the first 5 years, and then 5 years down the road, they will get a decreasing annuity of 100 paid continuously, decreasing continuously over 5 years. And the actuarial present value of the first increasing annuity is 100 times I bar A bar angle 5 at delta. The second one at time 5 is 100 times D bar A bar angle 5 delta, but we need to discount it 5 years back to today, and that's why we have this V to the 5th there. Okay, then we plug in the formulas for the increasing and decreasing annuity, which you need to memorize for the test. It's very important. And then we combine the like terms and do the calculations, and this ends up, after rearrangement of terms, this ends up being 100 times A bar angle 5 delta times 1 minus V to the 5th over delta. But A bar angle 5 delta is 1 minus V to the 5th over delta. So this just ends up being 100 times 1 minus V to the 5th squared over delta squared. We just plug in the value of delta and do the calculation, and it ends up being 1413.67, which is answer C. Please remember, this is copyrighted material. problems from past Society of Actuaries and or Casualty Actual Society belong to them, but the solution is mine. Such past problems are reproduced with permission. Good luck in your studies and good luck on the test.